All right, tonight we're going to take a look at an old Part 4 question from an older exam. And I kind of picked out a happy medium one. It's probably not the hardest one, but probably not the easiest one either. So a good one for us to cut our teeth on here tonight. And the first thing you'll notice as you read this opening paragraph is we're talking a lot about money and we're making an investment. When you see anything with regards to investment, I want you to imagine and picture two different formulas in your mind. One, we'd say the amount of money I currently have accrued is equal to my initial investment plus, or times 1 plus the rate divided by n raised to the n times t power. Of course, r is your rate, n is the number of times that investment gets compounded per year, and t is the number of years that have expired. Now, the other formula you may end up using is that old PERT formula, p times e to the rt, but we'll only use this one. We'll put a little disclaimer next to that one. If the interest is compounded continuously. Okay, so that's the magic word you're looking for in order to use that formula, continuously. So if it's compounded any other frequency, such as you'll notice here we're compounded annually on option A and we're compounded quarterly on option B, that means we're going to stick with this formula right here. And overall, I think tonight's not a bad night. If you want to try answering this question, write your functions for one for option A, one for option B on your own, and then you can kind of scrub through and see if we got the same answer. And you can do that encourage you to try part B and part C on your own as well. But you'll notice if you've read this opening paragraph already, we've got $5,000 to invest, and option A says the bank's going to pay him 4.5% interest compounded annually. So we'll label this option A, and we'll say A of t is equal to 5,000, and then in parentheses 1 plus, I'm going to move that decimal twice, so 0.045. Now it's compounded annually, so that's only once per year, and that would be raised to the 1t power. And of course those ones are strictly optional, and you don't have to put those in there by any stretch. All right, now for option B, let's see if I can switch colors here. For option B, going to use the same formula, but just kind of tweak a couple of little things. And this time I'll use B of t so I can keep the two functions, tell them apart. We've got that 5,000. This time it's 1 plus. We're going to go 0.046. And because we're compounded quarterly, that's 4 times a year. We're going to divide by 4, and here we're going to raise it to the 4 times t power. So there's my two functions, and that's all I got to do for part A. All right, moving on to part B here. All I did was I kind of imported the two functions we just wrote in part A, and I did clean them up a little bit, like specifically right here, I took 0.046 divided by 4 and added it to 1, so it just looks a touch cleaner. And I think we want to figure out, if I pull out that money in 6 years, how much more money am I going to have in option B compared to A? So what I'm going to try to do here is let's plug a 6 into both functions. So I could say A of 6 is equal to 5,000 times 1.045 raised to the 6th power. Type that into my calculator, and I'm going to round it to the nearest cent. So I've got $6,511.30. Okay, now let's go to option B, and we'll basically do the same thing. We're going to plug in a 6. Doesn't get any easier than this, does it? Let's see, 1.0115. This time it's going to be raised to the 24th power by the time I multiply the 4 and the 6 there. And again, plug that into my calculator. I'm going to get $6,578.87. And the question is, how much more money do I have in option B? So what I'm going to do is I'm going to subtract these two numbers. And we could say, okay, 6,578.87 minus 6,511.30, and that gave me $67.57. So not a huge advantage, but I'll certainly take it. And for part C, I think this is the most fun part of the problem. We're going to try to algebraically, and that's our favorite part, determine how long it's going to take for option B to double Seth's initial investment. And of course, his initial investment was $5,000, and if I double that, that makes $10,000. So I'm going to set that original function for option B equal to 10,000. And let's see what we get cooking. And we really get to showcase and kind of show off our algebra skills here. I'm going to divide both sides by 5,000. And that's going to make 2 equals 1.0115 raised to the 4t. And just a kind of insider tip, I guess, if nothing else, when you talk about doubling your investment, this number should always turn out to be a 2, because no matter what your initial investment is, this value is of course going to be twice as big. So by the time you divide this number to the other side, you're guaranteed to get a 2 no matter what. At this stage of the game, I'm going to go ahead and take the natural log of both sides. And so it's going to be the natural log of 2 equals the natural log of 1.0115 raised to the 4t. I'm going to take advantage of my log properties that say this exponent can get repositioned and moved down here in the coefficient slot. I'm going to divide both sides by the natural log of 1.0115. And at this point, I'm going to let the calculator take over. So in my calculator, I'm typing in the natural log of 2 divided by the natural log of 1.0115. Let's see what Mr. Calculator says there. It's going to give me 60.61958099 and that's only equal to 4t right now. And so I'm going to divide both sides by 4, and this time I got 15.1548 yada yada yada. You get the idea. And they said we want to round to the nearest tenth. So what are we saying for nearest tenth? Let's say because of the 5, we're going to kick this bear up a notch, and 15.2 years is going to be how long it takes to double his investment, which is pretty cool. So if you've got the time to be patient and wait, might as well wait. Maybe even wait even longer, and before you know it, it'll triple and quadruple maybe. So hopefully that bear didn't treat you too bad. Tomorrow in class we'll flash a whole bunch of Part 4 questions by you and see what you think.